Hello everyone. Here we're going to look at our first example on steady state heat conduction. And this example says we have hot water running in a stainless steel pipe with a 0.04 meter inside diameter, and the length of the pipe is 5 meters. And the inside wall is at 90 degrees Celsius, and the outside surface temperature is 88 degrees Celsius. Thermal conductivity of stainless steel is 16 watts per meter per degree Celsius, and the thickness of the wall is 2 millimeter. And we wanted to calculate the heat loss if the system is at steady state and it's not insulated, right? Because the outside surface is exposed. So this is a simple case of steady state heat conduction calculation. For a cylindrical shaped pipe, we know that we need to calculate what we call log mean area between the inner surface and the outer surface. Right, so we have our data listed out: the inside temperature 90 degree, outside temperature 88 degree. And we need to calculate our log mean area first. So for that, we need to calculate our A1 and A2 for the inside surface and outside surface. This is the surface of the cylindrical pipe. And once we find out about our log mean area, then we can plug that into our total thermal resistance equation for cylindrical shape geometry. Right, so we know our thickness is 2 millimeter, K is 16 watts per meter per degree Celsius, and we calculated the log mean surface area. And substitute into this, we can calculate our total thermal resistance. This is our total thermal resistance. And once that is found, calculating heat flow for conduction is very straightforward. As you may recall, as an analogy to the electrical circuitry, we take our driving force, which is temperature difference, across our heat conduction material. That will be T1 minus T2. And the thermal resistance we just calculated, and T1 minus T2 is 2 degrees Celsius, and R is 0.00019 degree per watts. Then we can calculate our heat flow is 10,526 watts. So it's very straightforward. The key here is to figure out what is our log mean area. Then we can calculate our thermal resistance, and from which heat flow follows very straightforwardly.